Ladies and gentlemen, we will start the webinar shortly. Just some reminders before we do so. This webinar is being recorded and is being live streamed in YouTube.
Great.
Questions from the attendees can be raised via the Q&A function in Zoom. All attendees may send their queries at any point in time during the webinar. The questions received will be reviewed and moderated for input to the discussion during the Q&A session towards the end of this webinar after all the speakers' presentations. For attendees who have any feedback, concerns, or requests, please send an email to saab.ntu.events@ntu.edu.sg. We will get back to you as soon as we can.
Hello, everyone. Good day to all. Welcome to this live Zoom webinar, Saab-NTU Joint Lab, Who Moved My Tower? The Digital Transformation in Air Traffic Management. Who Moved My Tower is coming from this famous book by Dr. Spencer, Who Moved My Cheese? Where the message was, if you don't change to the changes in the environment and technology, you are bound to perish. And that's what we see now in the changing world post-COVID. Remote tower technology has offered tremendous opportunity to meet the challenges that we are facing in terms of digitization, remote operation, and management of multiple airports by using this wonderful technology. So today we have an excellent panel of experts, 6 distinguished speakers: David Tan from the Economic Development Board of Singapore, Billy Josefsson from LFE Sweden, Niclas Gustavsson from Saab Sweden, Peter Gridling from Frequentis Austria, Jonas Lundberg from Linköping University Sweden. We'll be hearing them about their experiences and lessons learned. Also, they will give a glimpse into the future of the remote tower technology. We are going to cover a wide range of interesting topics, including regulatory, implementation, and operation challenges, as well as what are the ongoing trends and future research directions in remote tower technology. To start with, I would like to invite first Dr. Jovice, Director of Research at Saab Singapore and co-director of the NTU Saab Joint Lab, to give an overview of the research and introduce the lab. Dr. Jovice, please.
Thank you, Samir. Hello, everybody. My name is Jovice, and as introduced by Samir, I'm the Research Director for Saab Singapore, and also at the same time the co-directors for the Saab-NTU Joint Lab. I'm pleased to introduce you to Saab-NTU Joint Lab because it's actually part of the strategy for Saab to digitize most of our programs and products. And as part of the Saab digitalization research program, we actually selected several institutions from several countries to be part of this program, and Singapore is one of our very first partner to have this research center in Asia, and we've chosen NTU to be our partner in this sense. And we have actually signed an MOU with NTU during the late 2017, and we began our programs in 2018 on mainly focusing on the 2 programs. One is air traffic management, and the other one is the underwater robotics. So the main aim of this program is to bring our research from a low TRL of 1 to 4 into commercialization as quickly as possible by cutting short the time from research to commercialization. And we are very happy with our research collaboration with NTUs, and we have many good results coming from this joint lab. And we are pleased to present this very first webinar organized through the Saab-NTU Joint Lab. And we are pleased to have every participants and the speakers to be here with us. And I also wish you to enjoy this program and to have many good exchange and interaction. Thank you, and very welcome. And in Swedish, välkomna allihopa. Thank you.
Thank you, Jovice. Hi, everybody. Welcome back again. This is Samir from NTU. I'm the co-director of the Saab-NTU Joint Lab, and I'll be going through some of the research activities that we are doing at the lab. Okay, so in this presentation, I will be presenting a glimpse of some research results that we have obtained, only the research that has been published or under peer review. I will be presenting that in a short time. So as we all know that the airports of the future will be managed by data-driven and machine learning system. Especially the digitalization of the airport tower environment that we all are witnessing at the moment. This provides us a fantastic opportunity for designing and developing the next generation of decision support tools for the air traffic control. And such systems are needed to harness the digital environment and to manage the complexity at the busy airports where there's a lot of interest to adopt digital towers. At Saab-NTU Joint Research Lab, we have focused into 4 key areas when it comes to remote tower technology. First area, we work in visual detection and tracking and prediction of the airfield objects, both cooperative and non-cooperative. This is focusing on real-time video analytics. Second area is about data-driven performance metrics. As we know, this digitalized environment will offer lots of opportunities for coming up with new metrics. And air traffic controllers will certainly use new ways of understanding and acting upon the data provided by the digital environment. So this research looks into that. Then we have automated situation awareness, where we focus on how to fuse heterogeneous sources of data like computer vision, radars, sensors, and human gestures. Then we have program focusing on the human factors issues in remote tower operation, looking at predictive aids, workloads, and other psychophysiological indicators. I'll talk some of the research activities related to them now. So the first research that I'm going to talk about is the aircraft pushback prediction and the turnaround monitoring by vision-based object detection and activity identification. Now, as you all know, that the airport, runway, and taxiway are highly dynamic and complex environments. And there's a definite mechanism is required by the air traffic controller to understand when an aircraft is ready for departure so that they can plan an optimal pre-departure sequence when the aircraft can be dispatched from the gates. So in this research, we propose a visual analytic approach for detection, tracking, and tracking of the activities to predict the target off-block time. This research, we introduce a convolutional neural network-based video analytic framework, which can monitor and predict aircraft turnaround time. It also do the object detection, which is illustrated on the image. It can detect the aircraft, aircraft bridge, cargo truck, fuel truck, and all the activities associated with that. The algorithm recognizes an aircraft type and retrieves the turnaround processes and activities from the APM, the Aircraft Performance Manual, and then detect and tracks various activities and can do a real-time prediction when this aircraft will be ready for pushback. This paper is recently accepted and published in the CISA Innovation Days. This video shows how the machine learning algorithm is tracking various activities as they're happening in a fast time mode. On the left-hand side, we can show the CPM diagram, which illustrates how good the prediction of the algorithm is for the pushback time. The algorithm has a 100% aircraft type recognition accuracy. The data that you see here is coming from a live gate cam video from the gate number 3 at the Tokashi Obihara Airport in Hokkaido, Japan. The activity detection median error was 6 seconds, which is quite very low as compared to the overall pushback time, which is around 2,800 seconds. And the accuracy of putback prediction that was identified was around 80%. The next research that I'm showing is about object detection in the airport airside environment. As we know that the airport airside environment is very complex, have a variety of visual challenges, including hailstorm, snow, rain, low visibility, day and night. So in this research, we are proposing a computer vision-based framework, which we called as Deep for Air. It automates the visual monitoring of the airside operation by providing real-time data, including aircraft location, speed, as well as distance analytics. In the top right-hand corner, you can see this is the feed from a digital simulated tower. The algorithm can detect where location on the runway or taxiway the aircrafts are, what is their speed at the moment, and what is the distance between the moving object. This it do in the real-time mode. The video that you see in the below half is the digital tower video feed from the George Bush Intercontinental Airport. The proposed algorithm can track the aircraft, as you can see in the yellow bounding box, can estimate their speed, and as the other aircraft, which will appear in the video frames now, it will be able to track their distance in real time. So this is the other aircraft, United Alpha Lima 1160, and you can see that now the distance marker showing the speed between the two aircraft, completely based on computer vision. There is no sensor, no radar data here, and the performance of the algorithm, as you can see on the top graph, as compared to the state-of-the-art algorithm, is very high. And the next research which I illustrate is about the detection, tracking, and classification of aircrafts and drone in digital towers using machine learning algorithm. In this research, as you can see in this frame, there's an aircraft, there's a drone, and then there's a bird. So hard to identify by naked eyes. However, the machine learning algorithm that is developed here by using motion pattern detection can identify and track them in real time. This video, as you can see here, there's a drone and the algorithm is trying to learn that. First, it flips between drone and an aircraft, and then it understands that this particular flying object, non-cooperative, is a drone. We apply Harris detection, corner detection, and convolutional neural network for optical flow to locate and track very small moving object, especially in the wide scene area. The motion-based features were extracted from the trajectory, after which the K nearest neighbor classifier is applied to classify the objects into drone and aircraft. As you can see, the algorithm is very successful in tracking and identifying whether this is a drone. If I go back to the previous one, in this image on the left-hand side, the classifier classifies the aircraft and drone with a high success rate. Next research, which I'm mentioning about, is about the workload assessment in human factors in the digital tower. In this research, we are investigating what is the controller workload when they are exposed to a predictive tool. In this case, the tool that we are using is a drone detection algorithm that we have developed. In this simulated tower environment, we injected the drone in the NARSIM simulator and used an FNIRS, which is the near infrared spectroscopy systems, to understand the controller workload and the controller psychophysiological assessment. The result shows that the controller workload can be well managed and the situation awareness can be significantly improved by using such drone detection aid and display. This is another research where we are using spatial augmented reality at virtual airports. As you can see, we have 3D printed the entire Singapore Changi Airport as a Lego bricks. This is then augmented using a projection mapping. So there is a top-down projector that do a projection mapping, and you can see the aircraft moving around. Further, we have integrated the HoloLens, where humans can interact with the activities that are happening. There is also a Kinect sensor that is being integrated. And this allows the user to interact with the environment and play with the information. So this is just some glimpse about the research that we have done at the Saab-NTU Joint Lab. Some of the messages that I would like to highlight to the participants, that digital towers are more than just a digital out of the window view. However, they will remain so if we do not harness the digital transformation that we are looking at. However, it's just a matter of time before the busy and large airports will move towards the digital tower. And that's why we have to continue research efforts and safety validation to fully realize this paradigm shift. And eventually, this will lead to who moved my tower? And the tower will be moved to a digital environment. Thank you, everybody. Now, I would like to invite our first speaker, Niclas Gustavsson. Niclas is the Vice President of Business Development and Governmental Affairs in the joint venture between Saab and LFV. He drives the global development of the remote air traffic system markets, integrating system knowledge with the ANSP management know-how. Niclas, you may share your presentation. The floor is yours.
Thank you, everybody. I'll do that. And fantastic to be in such a nice crowd and talk. If you give me the chance to share my screen, I'll do that. So you give me the chance to share my screen. There you go. No, nope, not yet. So is this working now?
Yeah, it should be now.
Can you try again, Niclas?
Your co-host now.
Okay. Here we go.
Okay.
Right. Okay, thank you for that.
Go ahead.
Is it working?
Yes, go ahead.
Yeah. Okay, thank you. Sorry for that little delay. Niclas Gustavsson here from Saab Digital Air Traffic Solutions, a company set up to drive and foster the evolution of the digital tower. I'll give you a little bit talk on let's call it an industrial or way of how we see this landscape taking place, as our colleagues mentioned here. First of all, this is just a glimpse from the northern parts of Sweden, a new build airport with a full commercial traffic, but built from the beginning with remote or digital tower operated some 400 kilometers away. And it's just a good introduction to the fact that the future may look different and we can plan our airports differently, and you don't need to take care of having a tower in the middle of everything being in the way. And this was inaugurated actually more or less exactly a year ago. I'll give you a short video on that first. Yeah. And that was sort of the first landing, and they were operated, trained, and using only digital means as you saw in full IFR, bad weather, and doing all their services in that sense. Before we start, I think you looked at it and we talked about it. There is some kind of new landscape in ATM taking place. It's driven by technology, it's driven by the crisis, it's driven by the increased digitalization, the cybersecurity, but also the services that you could see with the drones and the air taxis, and then the environment is another part that drives us to make change. 5G is there, which enable us to do things, and autonomy as such, electrification of flights, and of course the things that we're talking about here, sort of pilot people and organizations that you actually can do things in a different way, like remote tower. But of course, the most important, there's a generation coming now. We are digital from birth as well, and this is sort of mentally accepted. And maybe from us as industry and research, maybe hold back a little bit to make sure always keep it safe and so on. When it comes to remote tower, I mean, of course, there's things like it is today when you have sort of brick and mortar towers. It's fixed, it's on site, you cannot move it. Once it's there, it's difficult to have it there. You have to have your staffs there. It's a little bit unflexible, and you cannot no mobility, security, and you have to invest in every airport and so on. The other one, if you go digital, you can centralize things. As you see in the middle there, you can have sensors on site and people in a center having another working environment, exchange information, knowledge, and so on. And you can actually future-proof the environment and having a different culture and way of working. So it's more than just a remote tower. I think it's a whole transformation or change process that we all taking part of, and adding to that later on the AI and the future tools that we talked about here earlier, then you will see a change. But we will strongly believe you need to digitalize, and then you need to add on things as you move on. On the picture now is the first airport that got live from Saab in 2015. And just to show you that it's the same, but still different. But many of the procedures are the same, and so on. And then from that, it has moved on, and you learn things from technology, or from operators, from regulators, and so on. This is the latest version going live in various places where you're slightly different, but the concept is the same, but you tailor it, you make it better. This is another one that is about to go live in Sweden in this case, and learning, and this is another one. And this is from Germany in another more military airport. The only thing I want to show, there's an acceptance and a growing industry awareness of this and how it's working. And I think we're getting ready to take even the next steps in these kind of developments. This is sort of the camera side. We have sensors. I'm sorry for that one being a little bit tilted upside down. It's sort of that from London City, which is in the middle of London. There's Germany, there's Sweden, and there's UK. So the skylines may change and so on. I must admit we may have to apply some architects or industrial designers to make it a little bit more nicer to look at. But it's sort of a different way, and the footprint is smaller. The way you use it is different, and you can place it more easily on an airport surface. So a new skyline taking place. Working on this, we at Saab thought, okay, there's technology and there's a big change from the users. So we combined, as you know, I'm from the operational side and Saab, but we also said, if this company is going to grow, we need to be both a service provider and a technology provider, and we need to merge very closely to make sure that the transition and the digitalization is sort of understood fully. And so if someone wants, you can offer both systems and operations at the same time, because somewhere, I'm not sure how and when and how it will look like, the business model will probably change also when you digitalize, as you've seen with other services, with your phones and your apps and so on. Let's see, it's just going to be interesting to see where it takes off. So currently Saab is operating a center in Sundsvall, which is in northern Sweden, with a number of airports, learning, developing, testing, and the stuff that Samir showed you probably will go there as well to be analyzed with real operational people. And I think we have over 5,000-6,000 people coming there to look, and we have an open door post-COVID to always have a look and chance and talk and so on. And there you see a center in Stockholm. There's another center being built in Schiphol with several things. So it's sort of it's taking place and it's happening, and I think that's just a message there. Well, if you look at a center or towers with all the features and various things, it may look in different ways, but we're spending a lot of time to try to understand how this could look in the future. You serve a number of airports centralized, you maybe integrate your training, you have large airports, you have regional airports, and you may have military integration and so on. But then in the reds here, there's probably other functions you could foresee, or we could foresee in the center as well, how you manage your drones environment and connect that to the various airports. You probably can have a good way of looking at your cybersecurity aspects and so on in your center. So that's something that connects to this change from who moved my tower. They probably will be moved into a center of towers somewhere, serving a country, serving a region, serving a multiple countries and so on. And there's one part that's already been talked about in this, and I just want to say, well, operating small airports with two airports by one controller, or 3 or 4, is sort of ready to go. And I think we spend a lot of our time now in making sure that this is ready and finalized, so you can actually operate 2 airports from the same position. That doesn't solve Changi or anything like that, but if you look at it, there's 40,000 commercial airports in the world, and some of these have very few flights a day, and you can create efficiency by doing that. That's also sort of something sort of COVID-driven activity that has been expedited. Just saying it's ready to go. And of course, if you look at technology, you started with this big way of presenting it. It may be going in a slightly different or various direction. You can have smaller working environment where you do a lot of things with less. And you can probably have, for large airport, a number of these modules serving a number of runways in a cluster and so on. And that's also part of where the technology enhancements that we showed earlier can help the ATCOs or the staff to perform and make their services reliable and efficient in many ways. Right. I just want to share another little track on that. Looking at those remote tower for Saab, that was just the start of something. Digitalizing and understanding you can do things differently. And one of the things is, how will, and I think that's don't have the answer. The future airport, the autonomous airport, it's more than a tower, and you probably can see how, I think rapidly here, the different things. It's very detailed here, but the airport with all these technologies I showed you, with maybe the drone port, is that at an airport or different? It probably both, but it probably will live and get fueled and get electrified at the airport, and somewhere or another. There's probably air taxis coming there. There's probably other where you have new planes. So it's a mix of things, most likely, at that. And you have air traffic control, as we talked about, remote tower at the airport or somewhere else in this area. It's also links to the airport operations center. So there is this ecosystem that is coming around, and I think some of the stuff on the remote towers is sort of driven and fueling this sort of vision on how you share data and have the abilities to do that. Looking from a remote tower, I think, and from a market perspective, I strongly believe that the crisis will drive this change. Let's assume that at one point in time there will be no traditional towers for the reason, and then replaced by the digital and the remote versions in various kinds. And what we've seen from Saab side, that the COVID actually will change the curve and make it grow faster or steeper and so on. And I think that also puts relevance on all the research done by NTU and others in order to support this development of the market. Well, thank you very much and for taking the time here. Thank you.
Thank you, Niclas. That was very insightful of you. Our next speaker is Billy Josefsson, who is head of the automation and human performance at LFV, the Swedish air navigation service provider. Billy has an air traffic controller background with all the endorsement for civil and military air traffic systems, and as well as an instructor rating. Billy has more than 20 years of experience in developing the remote tower concept and is very well known in the research community. Billy Josefsson, welcome, and the floor is yours.
Thank you. Is the picture okay?
Yeah, go ahead, Billy.
Yes, thank you. Thank you for the opportunity to share a few thoughts from an air navigation service provider perspective. We may be seen as quite progressive, as we have a research and innovation department, but this is all very interesting to me, and I also realized that I've been in digitalization of things since we get rid of the paper and went digitalized with the en route system some 10-15 years ago. And I also was in the beginning of the RTS and RTC definition and testings. So what I'm going to say today, I will suggest that we turn the situation we have now with the COVID and the new prerequisites into an opportunity. And I also would like to reinforce that the digitalization is the prerequisites to go into higher levels of automation and what kind of opportunities that may give us. I will give you a few examples of the research and the projects we are involved in, and also I will go through the evaluation of the efficiency at an RTC, what that means to us. And I also will present the teams. And next slide, please. Yeah, here we go. So this was a flyer that was circulated early this year, talking about a lot of insightful things. I would like to focus on the top 3 opportunity things, where we're talking about the opportunities like improving the service scalability and resilience, in particular, the ability to cope and stand towards future variations. Also, collaboration. We all realize now we have to collaborate and share things, work together to make the new normal be good for the airspace users and a good environment. And that's what we're doing now. And the focus today is the faster uptake of the technology, the digitalization, how to integrate higher levels of automations into our operations, that we need to speed up that a little bit. And I think we can do that because low traffic, we have availability of operational people, and that used to hold back a lot of activities in the past, but now they are there, so we just organize that. And whatever we come up with, I think we could meet the regulatory restrictions quite well because of the number of traffic is quite low. So it's time, I think, to move the tower before someone else is moving it. And we also heard about the curve earlier, and we should be bold and brave. Think outside the box and not preserving what we have today. We have to be ahead of the curve, which means that we, from an ANSP perspective, we have to recheck our R&D plan, investments plan, our priorities, because it's not the same today as it was in March, early this year. It's a dramatic change. And we need the help from the research and development and the industry to go ahead. These things, the story about the towers, it's not so old, some 100 years maybe, but the evolution is there, and it was also stated some years ago, no need anymore to build any new towers. So what can we do with the towers? Yes, we can just abandon them, but we also could convert them to hotels, cafes, restaurants, and so on. But in general, we just have to understand that we have to invest, and that can be justified to come to a better position in the future from an ANSP perspective. And we all, I think, seeking for the argument to invest for next level of automation, next level of service precision. And from an airport manager perspective, I think it would be smart. I realize I will stay in the business after the COVID. I better organize my business, link up to our remote tower center as soon as possible. And then, of course, I could be able to provide the air traffic services on demand. And I may do less money, but it will be cost efficient and it will be part of the future. I may do business another way, but ATS on demand will increase. That's a clear message from the society and the aerospace users to cut down the costs. So, coming back to digitalization and what that enable, and the digitalization, this is a complicated picture. You can study it in the CSR master plan closely. I recommend that. But simply, we have to move our service to another level of automation, where we better integrate the technology that is available today together with the human. We have challenges in terms of risk and safety assessment to get these things approved. But I'm convinced that we can do this as we collaborate and sharing best practices and uses also the new technology to demonstrate that this level of automation is safe and resilient. So we have some work ahead of us. Level 3, that's what I like to go. Many projects and research are going on. I will mention one. Look out for that in the future. The report is coming early next year. The Safe Tower project, where we study actually the current and try to learn where digitalization all information and analyze where and how we could run the future operations. And we already seen this, and we also know that with this context, we can rearrange the visual information. We can use sensors like eye tracking, speech recognition, attention guidance to present information and provide a good data for the operator to take efficient and the optimal decision. And by doing this reorganization, this nice environment, and support the operator, we really optimizing the human performance and also, of course, support the safety performance. This is a dual operations. In our research lab, we have at Linköping University in Norrköping. I take an example of digitalization of a physical environment, just from the cockpit. So what happens with the airline used to happen with the NSPs. This was demonstrated recently, how they use the virtual reality applications to do familiarization training for procedures in the cockpit. Also, it was demonstrated to have briefings or debriefings in a virtual environment when you are distributed all over the place. And you also can train on practice interactions and so on. And we all know the global discussions on how much of the on-the-job training can be replaced by other means, CBTs, simulators, and even virtual reality, augmented reality applications. So for me, from an NSP perspective, I like to do it as much as possible outside the ops room, of course, because that is more efficient and more cost efficient. So coming back to our lab towers and the airports, today we know what to do today. We have the analog towers, we have the RTC. We can digitalize that further, take that information and put it into an environment where you can just, using the VR Googles on that, we can further refine that view by taking out all unnecessary information. And that is a tremendous effect. It's just like putting a noise cancelling on your headphone. You can even take out maybe the grass and the trees and so on as well. So there are more steps. So maybe this is a possible way forward to even provide services or maintaining multiple endorsement from an RTC environment. There is a few opportunities. So I had a dilemma which project I would like to talk about, but I'd like to show a glimpse of a project that started earlier this year. It's based on previous work with the LFE and Linköping University, but this project, Objective Verification of Competence, is really interesting because we link it to the training and the verification of competence situation in the first stage. So imagine if we can objectively assess the operator's performance and balance then the subjective assessment of the operator and the student that the instructor does. And this objective assessment is done by the machine and the system. It could also be provided directly to the student without informing the instructor at all. And the instructor could be elsewhere. And the instructor or assessor could also look after several students in this way. So we can do that, and that is interesting. Oh, sorry. And we started these workshops with instructors, and trials will take place early next year with a number of controllers. And yeah, we're using all kind of data collection like eye trackers and so on, and a nice model to model and to analyze and visualize the result from this. So we're looking forward to inform you further on this, the outcome of this project. Also, I'd like to share this with you because I took the opportunity to ask a number of well-informed people on how they would like to put priority to a few projects, a few initiatives, which are heavily laying on digitalization. And as you see, airspace optimization for all airspace users, including U-space and the UTM and so on, that was a high priority. So the airspace need to be really digitalized, and also everything that goes in there, we also should digitalize, and then we can process and optimize the usage of the airspace. And the number two was actually the training situation, as I just mentioned. So that seems to be high on the agenda, and of course it is, because it's costly, and we could take steps there to make it more efficiently. Also harmonization, like increased flexibility, that's very relevant, because it builds on digitalization and systemization of procedures, and you put the geographic specific information into the system and not in the controller's head. Multiple remote tower, wow. That is great, and we foresee that this will bloom in the near future, because it's so timing to, we are late, but it's so motivating to achieve this now, and we just have to organize the risk and safety assessment properly. The technology is there, and when we see one operator managed 2, 3, 4, 5 airports, then we'll see a real benefit to society and airspace users. And digital assistant, we will hear more from that later from my colleague Jonas. So quick poll with these people, interesting areas, heavily related on digitalization. So we should not be afraid to move on with what we think. Here comes one of my main messages today, which is an evaluation of the efficiency of an RTC of moving 5 airports into one center. This was reported very thoroughly on the CESAR Innovation Days 2019. So the full paper up there for download if you like to move on further. Anyway, these 5 airports scattered all over Sweden, and 4 of them are subject for the new RTC in Stockholm the coming year. Anyway, we can see that by putting these 5 airports in an optimized way, optimizing the number of controller working position or remote tower modules, and optimizing the traffic load and minimizing the switches and so on, and many trade-offs, and the number of endorsement needed, optimize that, and of course minimize the number of controllers needed. Considering all these trade-offs, we also found very promising results. For instance, the seasonal variations that could be mitigated because that varies also over this. You see with quite large percent. Today, it's really heavy. And the number of controllers you need in an RTC compared to running the individual airports is dramatically lower. We investigate the highest traffic day And then we also made a worst case scenario.
I think we have 1 minute left. Thank you.
Yes. Thank you. So, yes. So a quite good ratio you can save by putting things into RTC from an HR performance point of view. Okay, very quick. The safety performance is there, and the benefits by having an RTC. We see sharing, learning, and everything is recorded, which is really good. I guess this is also a summary. We have to collaborate cross-industry, cross-border, otherwise this will not happen. And also cross-research and innovation as we do now. And here are the team from 9 countries, and we love to work with you, and we do. And so you can join this team. And these are the people we have to have in our business from an ANSP point of view. These are the people I must hire. I must attract them. And that's why I need also to make the work attractive. And I think we're going the right way with the digitalization and new technology into our business. Thank you.
Thank you so much, Billy. That was really inspiring talk. I think just like Trump Tower Hotel, we should have a ATC Tower Hotel registered very soon. Okay, our next speaker is Jonas, Professor Jonas Lundberg, who is a full professor in human-centered design at Linköping University. Professor Jonas has docent in cognitive systems and a PhD in computer science. His main research is in visual collaboration environments for human engaging with autonomous and automated system. Jonas, you may share your presentation. The floor is yours.
Can you hear me now?
Yes, loud and clear, Jonas. Go ahead.
Great. I will then proceed to share my screen.
So by the time Jonas is sharing the screen, I would like to inform everybody that we have over 160 participants live watching this webinar at the moment. So this highlights the amazing interest people all around the world have in this technology. Jonas, go ahead. Thank you.
Can you also see my screen now?
Yeah.
You see my screen?
Yes, go ahead.
So, thank you. I will talk about human-machine collaboration. Specifically, I will talk about how air traffic controllers can collaborate with digital assistants. That is a highly automated and autonomous air traffic control system. And I will talk about how operators can be supported in this collaboration with AI-supported situation management and training. Further, there were no digital assistants when we started, so we are designing and prototype those digital assistants as well. So let me first illustrate the problem. Here we see an air traffic controller working with 2 airports. That's Kiruna and Linköping. And you see how they work with these 2 parts of the screen. And here they focus on a landing on one of the airports. But what happens if there are 2 simultaneous landings at the 2, both in Kiruna and Linköping? Should we then delay the aircraft in Linköping so that the aircraft in Kiruna can land first? I mean, that's not really reasonable, right? Should we devise a complicated rotation of ATCOs between airports? Or to always have an ATCO in charge? Should we have an ATCO on standby? Or should we move to supervisory control of at least 1 airport to an autonomous system? And that is the concept that we're going to discuss. What if the digital assistance controls traffic at 1 airport? And as you can see in this image here, in the green airport, there's just 1 aircraft arriving, whereas on the other one, there is several aircraft and ground traffic. So let's say that we delegate the low traffic airport to the digital assistant. But then the question emerges, is it safe? And how can we ensure that the air traffic controllers are well trained to work with a digital assistant? And then we have to return to the levels of automation in air traffic management that Billy showed you previously. We look at section 4, high automation, which is near the goal of the air traffic management scale here. We see that automation can initiate actions for most tasks. But how about the other tasks? And how about the tasks that are involved in this specific situation? Can it work with those? And it says initiate. How about completing them? Can we be sure that it will complete the whole movement, or will we be required to take over in the middle of this maneuver? Further on, we see lower down here that this stage requires adaptable automation concept to support optimal socio-technical system performance. And how can we achieve that? Well, we have to look beyond this division of labor that we see here, who does what. We have to look at the competence here of the machine, and we can look at the levels of autonomy and cognitive control, and we can look at what the human end system can control together, what the air traffic controller can do, and what the automation can do. And these levels you see here are not probably that problematic for an automation engineer. They're about making overarching plans at level 3, implementing them in specific situation at level 2, and keeping track of object statuses at level 1. I think we're fine there already in the technology development, and perhaps this is not always where we want the human involvement. But if we look at these levels here, we look at prioritization, level 4. We look at the framing of situations, ability to recognize and to formulate approaches to manage a variety of situations. And based on that, to formulate the desired effect goals in specific situations. That's much harder to develop. But we have to keep track of where we are. What is it exactly that we need to work with? Do we need to collaborate on goal formulation? Is it values, or is it plans? What exactly is it that the human and machine should collaborate on? And of course, to get somewhere, we had to conceive a concept of the digital tower assistant, and we have designed this together with the LFV and an air traffic control expert at LFV. And we will test this as a specific scenario, as you can see here. And we are also implementing a prototype of this system. And it's what we are looking here is the data competence and teamwork requirements are at the core of this concept. And as you can see, it starts outside the sector here and goes towards Linköping Airport in this scenario. This is what we see. And what we will also need to do then is to analyze the interactions that occur in this scenario. And we have made an analysis tool to understand the emerging operational concept and the human-machine interface for collaboration during operations and during training. It uses these same 6 levels that you saw in my previous slides. And we can analyze the air traffic controller controlling the digital assistant. We can analyze how the data monitors the airspace and how the data then controls the aircraft. And using this tool, we can move decisions and events in time to explore consequences. We can model and explore alternative developments. Just a quick view into this tool that we're building. And the goal here is to design, one of the goals is to design automation transparency, to make an HMI here, a human machine interface, to reskill the operators and the focus is to help them work with the new AI system, rather than, as I think has been done too much in previous research, which is to focus on maintenance of manual skills only, or to only focus on difficult handovers that we would rather actually avoid. And this is design work in progress that we will test in spring 2021. Therefore, I will not show you our HMIs at this point. And what we will use as one of the core technologies is unobtrusive eye tracking. And that is because these environments are highly visual. They use large displays and often also information dense situation or radar displays to build a picture of the situation, to diagnose the past, and to predict the future. And what we see here, some things that they see are cues that alert them to events, and others are specific items that you need to pick up, for instance, the wind direction. And you see some close-ups of the cameras here. This is a system, Smart Eye has developed this system, and it consists of 6 cameras placed in environments, which means that we don't need to mount a lot of equipment on the controller. And here you see the output of this system, which is the eye point of gaze from the head of the controller onto the various displays to precisely show exactly what they are looking at. And of course, we get a tremendous amount of extra variables from this gaze data as well. And one of the concepts that we're working on, we called soft visual cues for attention guidance. Not all things that we want to communicate from the automation is an alarm of something horribly gone wrong. Some are gentle reminders. Have you seen this? Have you seen that? And as you can see, we have a visual scan pattern on the left, where the ATCO is working on something and they have missed some information on the screen C here. And our idea with the soft visual cues is that they should not see this reminder until they focus on screen C. And this is not something that should replace alarms, but something that should be used together with alarms. An additional concept. And I show some references here so that you can all read later. If you can't access any of these, you can send me an email and I will send you these references. I would also like to say that we're working with instructor support systems. Billy showed a similar slide previously. And we're working in several ways here. First of all, we use this eye tracking system to detect these sequences of gaze that go between screens and objects. Then we can use data mining to find patterns. We can visualize these to show the instructors how people actually work, their students or experienced controllers. And we can interactively explore these gaze patterns with our tools that we develop. Then we can discuss this with instructors to see which of these are desired. And then we can devise online tools that in real time check these gaze sequences. And that's a part of this OVAC project. Lastly, I would like to emphasize that this is a joint effort between LFV and Leo in developing these concepts. We also see collaboration with Saab here in the use of their remote tower software. And there's not just me, but a lot of people, a large team working on various aspects in this work. And that's all from me.
Thank you, Jonas. That was quite interesting. I just worry about a day when the digital assistant will become a digital boss and the human boss will become a human assistant.
Yeah, I don't think that's a very would be a very good thing, actually.
Okay, our next speaker is Peter Gridling. Peter is Vice President Sales at the Frequentis DFS Aeroscenes. He joined Frequentis in 2016 to support the digital tower team. Peter is a graduate with an engineering degree in computer science. He's a wizard in computer vision with a very strong background in digital tower technologies. Peter, you may load your presentation. The floor is yours.
Thank you very much for the introduction. Can you see my screen?
Yes, Peter, go ahead.
Yes, perfect. Yeah, my name is Peter Gridling. I'm Vice President of Sales of the joint venture between Frequentis and DFS, which has been found 2 years ago. And why we have found this joint venture? Because Frequentis and DFS connects a very long history of remote tower research, development, and finally also the rollout. So basically, when we are talking about remote tower history, then we are talking not about a few years. So basically, the first concepts have been already developed and created in the early 2000s. And of course, at this time, technology was not far enough. So basically, it kept to be a research topic, but we permanently evaluated possibilities, and finally that led then to the successful rollout project in Germany, where we have started to operate the most advanced remote tower and the biggest remotely controlled airport worldwide so far in Saarbrücken. And since then, we are constantly rolling out different projects. So we are involved in the meanwhile in 9 different remote and digital tower projects worldwide in different countries with different use cases. And of course, we have gathered a lot of experience in this field. So when we have a look to the world map, then you see that the technology Frequentis provides is really spread out all over the world. So in the beginning, focused on Europe, but in the meanwhile also with an established footprint in South America, also for the US Air Force and US Navy. So here we are also evaluating a military use case, and last but not least, also the introduction of remote tower technology in New Zealand. And what's interestingly, we are not focusing only on one single use case. So we have seen that there are multiple use cases for different sizes of airports, for different types of environments. So basically, we find our technology now in very small airports, and not only ATC airports, but also AFIS airports, where we have a very simple digital tower solution. Then, of course, the classic field of remote towers, where we remotely control airports from a distance. And last but not least, also we find the technology now more and more in large airports, where the technology is used as a support tool for the controllers, either as vision enhancement, but also for a contingency use case. And of course, there is no standard solution for all these different types of airports and different types of use cases. And to give you a small example, I show you here 4 out of those 9 different use cases, so that you can see that from the working position side, the systems are quite different. So you see a very compact solution in Ezeiza in Argentina, where the system is used as a vision enhancement with visual and infrared sensors. So here it's about that the controller sees the airfield better, and also to cover blind spots, for example. Then you see the working position in Leipzig in the DFS remote tower project. So here you have a compact working position with which the controller can very efficiently use the technology to control the airport of Saarbrücken, which is about 450 kilometers away. Then you see a digital tower solution in Santa Cruz, which is using a large video wall concept with 16 screens. So here are also multiple working positions in front of this large video wall. And last but not least, also a little bit a smaller video wall concept for Auckland in New Zealand, where you can see 11 screens and multiple positions in front of the video wall. So you see basically a lot of different possibilities how a remote tower, a digital tower solution can look like. And maybe let's go a little bit deeper into the German project. So the German project was started in 2015, and the first airport where Saarbrücken went live at the 4th of December 2018. And basically the demand of DFS was from the very beginning on to provide more than just the out of the window view. So basically, since of the long history, it was foreseeable that the technology is working. The technology now is far enough to provide digital and remote tower services. And also in Sweden, it was successfully shown since 2014 that the system, the concept, the remote tower definitively works and provides the possibility to provide safe air traffic control. So the concept and the demand of DFS from the very beginning was to provide more to the air traffic controller. They didn't want just to replace the out of the window view and to replace the binoculars. They wanted to create a support tool for the controller to even control the airport more safely and with reduced workload. And that was the motivation why in this concept of DFS from the very beginning, two major differentiators to other projects have been implemented. The first one is the use of infrared technology. So basically, the controller has the possibility to switch between the visual and the infrared sensors to enhance the vision during times when the visual sensor have only a limited view. This is, of course, during night times, but also in fog conditions, for example. The second major feature is the automated object detection. So the system has already the possibility to automate detect objects which are non-cooperative. So here the system provides a support tool to increase the situational awareness of the controller. And last but not least, also a very important tool is the automated camera tracking. So the PTZ camera are able to automatically follow objects, and that reduces the workload for the controllers a lot. And while the main motivation at the very beginning of the implementation of remote tower was, of course, to save costs. So what we have learned in the German project was that they are saving up to 18% of operational costs. That comes because of the more flexible staffing in the center, but also because of harmonizing the technology in such a project, and also to save costs at the technician side, for example. Another motivator for DFS was that the tower in Saarbrücken was end of life, and they had to think about, okay, will we renovate or rebuild the concrete tower, or will we implement a new technology? So basically, they decided to implement remote tower and saved here almost 80% of the investment costs for a new tower. But then, when we are looking a little bit aside of the costs, we have realized that also the workload for controllers, because of those additional features and because of these additional support tools, was reduced. So here we see a clear benefit, and especially at smaller airfields, we see then also that this reduction of workload leads to a slight increase of safety. So if you have features like a virtual safety net, for example, when you bring in the possibility to have a safety net in very small airports which don't have ground surveillance, for example, then you create additional benefit to the controller and additional safety features, which leads to an increase of safety. Now, with these achievements now, what you can do with that possibility. And first of all, Frequentis at the moment is working on two different strategies. First of all, and that's what we are currently rolling out in Denmark at Billund Airport, is the combination of tower control and approach control. So basically, remote and digital tower technology provides you an increased flexibility so that you can combine different roles. And in Billund, we have the concept that during daytime, we have two different working positions, one for tower control, one for approach control. But during the night, when there is low traffic, then one single air traffic controller will execute both roles. And this is simply possible because of the integrated approach of such an environment. So basically, we have created a data integration platform which can exchange data and information in real time between different systems which have been split up in the past. And here we are working on different additional support tools to support the controller even more and to reduce the workload, so that the control of the combined roles, approach and tower, can be safely executed. Another strategy is the introduction of multi-remote tower operations. And Frequentis did a huge effort in the past to evaluate this concept. So we have been involved in 5 CESAR evaluations where we evolved this principle and designed together with controllers the possibility to control up to 3 airports by one position. And in 2019, we have been the first company which executed a passive shadow mode operations together with Hungaro Control to evaluate if this concept really is able to control 3 real airports. And the test was very successful. So basically, we have proven that the concept works, that one single air traffic controller can operate 3 airports at the same time simultaneously. Of course, there are some pre-requirements, so this concept will not be able to be implemented in all different kind of airports, but for small airports with low traffic numbers, with low complexity, this concept can be definitively implemented. And what you see here is what the view of the controller was. So basically, he saw all these 3 airports at the same time. So one of the learnings of the controllers was that they prefer to see all 3 airports at the same time, not to switch between the airports because of the situational awareness and the loss of situational awareness, and to have all the data they need to control the airport directly at the screen and with the specific support tools. So we have created a special planning tool, and we also have integrated the voice communication system directly into this concept, into the HMI, but also to have a visual indication for the radio calls. And we see that within 2 to 3 years, we will have the first multi-remote tower in operation, definitively. So now what we are also doing at the moment in research topics is to create even more supportive tools. So we have a strong research at the moment benefiting out of the topic of artificial intelligence, of course, for the image recognition tasks, but also for the voice recognition paths. So a potential possibility would be that AI checks the clearances given via radio, and if the pilot, for example, is reading back the clearance in a wrong way, then there could be an alarm, for example. So here is another potential possibility of the use of artificial intelligence.
1 minute more, thank you.
Yeah, and what we also saw in the past few months is that the technology could be used in a more broader way. So basically, it can support the business continuity of your operations. Think about pandemic crisis. So social distancing is much more easy to implement in a digital tower environment than in a small tower cabin. But also think about other threats like natural diseases, like terrorist attack, where you have a threat concerning the concrete tower, and to take over and keep up operations, a digital tower solution can be the perfect way. And the basic takeaways I would like to remember you. So our experience in 9 different projects has shown that there is no standard system for all different cases, use cases and environments. So the system should be flexible enough to adapt to your concept of operations, and the concept of operation should not adapt to the technology. Digital tower technology can save costs, but also increase operational safety at the same time. So that's very important. That's also one of the major learnings we made. And digital tower technology can support your business continuity plans at almost every airport you can think about. And I believe that we will find digital tower technology in 10 to 15 years on basically every airport. So thank you very much for your attention. Bye.
Thank you, Peter. That was very insightful, and it's very heartening to note that industry is moving very fast, both Saab and Frequentis, in realizing the transformation and making this digitalization come to fruition as soon as possible. Our next speaker is Mr. David Tan. David Tan is a Senior Vice President at the Singapore Economic Development Board. He currently serves as the head for the Office of Space Technology and Industry. David was a UK qualified master air traffic controller in the Republic of Singapore Air Force for 30 years, and he was responsible for air traffic, air defense, and airspace management. David is also one of the initiator of the digital tower concept in Singapore, and what we see realizing today is because of David's efforts. So David, you may load your presentation. The floor is yours.
Thank you, Samir. Let me try to load. You will give me the sharing capability?
Yes, you have. Go ahead.
Do I?
Yes, please.
Okay. Can you see my slide?
Very well.
Okay, good. Like to keep within the next 15 minutes to share a little bit on the design that I was involved previously in looking at design for decision support systems in both the air traffic as well as in air operation. Now, I want to talk a little bit about the making sense of sense-making on cognition. So this is really to be able to contribute to the thinking behind modules in AI. But let me just now do a little bit of a definition of cognition, because this is really coming from the Latin word cognoscere. This really is talking about knowing, recognizing, and the capacity to conceptualize. Really, the process is to leverage on our sensory memory, our short-term memory, our long-term memory to be able to learn, to remember, to understand, and most importantly, to perceive. The perception is important in order for us to make decisions. And in air traffic, which is a very complex operations, we need to be able to understand how we take decision into a point of decision. I'm using this a Cognition model propounded by Dave Snowden. And really, air traffic is a very procedural operations. Air traffic likes to be mastery in the known and novel space, and perhaps at best to be able to deal with complexity. The last thing they want to get into is actually in the chaotic space where they cannot make sense out of it. And the nature of air traffic is such that they can always develop standard operating procedures, know what they need to deal with it in the books, and have best practices. And they do it very well, and they can respond very well. They're very optimal with their sensing. They can categorize when situation turns up. But they are also mindful that in cases where there are novel situations that they have to deal with it, experts' judgment comes in. They may not have experienced aircraft crashing in the airport, but they know this thing can happen. They go into scenario planning, and quite a fair bit of analysis tools are being built into the system. At the end of the day, when they cannot potentially foresee things that can happen, which is in the complex space, they need to be able to build that ability to have pattern recognition. And so some people say that the world are divided into two sets of order, the ordered one, which is in the past, and the unordered, which is frightening. But I like to believe that we're all in a mix of what I call the disordered world. If we understand this complexity, complication, and the simple, then we can think about how air traffic operations will need to be able to operate when you design systems thinking for them. So the question, how does air traffic develops into a complexity? From a very simple single runway operations in the airport, when you start to operate multiple terminals, multiple platform, multiple runway, then you increase that complexity tied to the controller's workload. The question is, how do you deal with them, and how can machine comes in? This is where I give an example of Changi. Changi is not quite an airport, but it's an air hub. If you look at current situation we have with 3 runway operations and working towards 5 terminal, then the questions that you ask yourself as you develop an airport into an air hub, or when you strengthen the air hub capability with more footprints as well as infrastructure, the question is not how many air traffic towers should you build, but how can you reduce coordination in a complex operation? That's the kind of question we ask, and we ask ourselves, how do we then go into the design? Air traffic controllers are constantly mindful about how they can handle capacity, deal with intrusions, deal with resource management, incident, accident, and do so on a 24/7 basis. How do you translate all this into decision support capability? So here it is. We are asking this question of how do you develop sense-making capabilities beyond what the eyeballs can see. Many of the speakers have spoken about it, but I would like to introduce two designs that we can take into consideration. One is the augmented cognition, to be able to provide contextual reasoning as part of decision process, as well as the one smart glance for rapid cognition. Let me just elaborate a little bit. We all know very well that controllers requires evidence-based, whether explicit, implicit, or tacit, and transfer this expert knowledge from their many years of experience into critical cues. And they built up this into a knowledge corpus. Sense-making can allow them to be able to very quickly translate and operate in very different scenarios, from a very simple to the complicated and the complex. These decision tools, when you break up into augmented cognitions, can help them to develop decision processes to deal with consequence management. How do we do that? We must recognize what kind of perturbation comes into the mind. The motivation is to help the air traffic controller to have cognitive capabilities and to perform beyond the level of what a single human can do, looking at speed, accuracy, and developing anticipatory capabilities to help them make decisions in complexity. Part of this is to be able to augment real-time, multidimensional informations in space, in time and space, in events, in planning. But you know that the human element has limitations in trying to remember everything. So you want to build that situation to help them make decisions. For example, what are the watch area to monitor? Where are the schedule in conflicts by window? And what is the capacity over time? And what are the rules in English? You build all this as part of the reason mechanism. And then you take into context the reasoning, build it into the procedures that they can be either reactive or anticipatory, and then bring in the systems onto the screen to be able to help them see things in perspective. All of this comes into play so that they can know exactly how they make decisions and enhance their experience. For example, what is normal, what is not normal? How do you deal with the impact, and what are the responses? And as you do them, you guide them. As you guide them, you turn into various engines that help them to make decisions. So these are some of the examples. So this is one of my last slides that says that you can actually, and this is, I think, I could use this to try and build consequence management, self-synchronizations, collaboration, because airports are constantly building into what I call the airport collaborative decision-making process. People can work together and make decisions in a guided manner. So on this note, I thank you for your attention.
Thank you, David. Thanks for the great insight from your experience. Now we open the floor for question and answers. But before I do that, I would like to thank all of our speakers and to give an insight from air navigation service providers, researchers, as well as industry. So it was quite interesting to hear from a good mix of our guest speakers. In fact, we got over 30 questions in total, and it's very difficult to answer them in the webinar today. So we will try to take a few questions, at least one from each speaker. However, we will be emailing the questions to the respective speakers, and we will post them via email back to the people who have asked the questions. So I can start with the question about from our first speaker, Niclas. One of the attendees have asked, I am curious to know about the security aspects of digital tower. How secure are they to hacking? Question from Sundar Sen. Niclas, your microphone is mute if you can. Thank you.
Yeah, thank you. I think the security is always sort of a key questions that comes up, and of course it is a digital system. It's a connectivity between sites most often, and there are systems. And I think the first of all, there's two things. There's a redundancy and keeping it alive, and that can be at different levels. And I think the cybersecurity is a key thing if we're going to have trust in this in the future, and it's an increasing threat. So from Saab, I think we are working to sort of integrate at various levels. It's at the network level, there are things you need to take care of. Make sure that you have your overall outer shell of networks protected. That normally maybe lies on the ANS provider or the airports and so on. But that's something that needs to be there to make sure it can be about encryption and various levels. But that's not enough. I think it's as in any kind of safety or live system. We started to look at how is the inner part of the apple, if you may, so security when it comes to in the center, how you protect the system for intrusion, which is unintentional or intentional, from the worst sort of scenario of a third sort of outside wanted to harm you, and that goes, and then there are different solutions on how you come to that. And I think that's something that you have to apply and have to be judged, and it's part of the regulatory approval. It's not only safety, it's also security. And then there is a balance, of course, as you all know, between you can have an absolutely secure system, but you cannot operate it, and maybe it may jeopardize safety. So I think what we spend, and that's including some of the stuff you've seen on the academic work, how the balance between safety and security should apply. So you have the balance of these kind of two things. I say it's secure. We haven't had any breach, as I know, which has an impact safety or anything like that. But I think it's top of the list of things that you need to spend. And as me and maybe Peter also said, is moving into the military area, and they will see another layer of security aspect that needs to or will be part of the remote and digital tower products and implementations.
Thank you so much. And next question is to Billy by Thierry. Thierry wants to know, is there any study on the impact of the time needed for a controller to be fully qualified and obtain all the European license ratings on each of the airport he would like to control? And what about the capacity to be qualified and maintain qualification on several airfields at the same time? Billy. You are mute, Billy.
Yeah. Yes, thank you. A very good question, a very relevant question, which we work since quite a long time to understand how to manage that and how to also keep the endorsement alive and to meeting the regulatory requirements on that. It's not easy. The regulator has stepped back a little bit on the requirements, so we have more flexibility now. You see that for the en route in particular, and as we're going along the line with harmonization, and we can have also an objective assessment of the performance, like on the actual performance, and also inject support to keep the endorsement alive and demonstrate that these mitigations is relevant, like simulator or using VR goggles or whatever. So there is a bit of scientific effort needed here. Sorry, I'm not really fully up to date, but I guess we have at least 3 endorsements, people who have 3 endorsements today at Sundsvall, where we have 4 airports. And we haven't pushed that further. So that's the situation right now. But this is an important question which needs to be understood and supported by academic research and field research. Thank you.
Thank you, Billy. Next question is with Jonas. Jonas, Zina would like to know, what do you think are the most important human factors issue when it comes to the remote tower? Workload, stress, trust, vigilance, what do you think?
Well, I think the most important concept is none of these. It's to avoid what I would call a hot handover. We don't want anyone, air traffic controller or otherwise, to just get back a situation that automation could not handle. And let's say it's a critical situation, they might only have seconds to respond. We don't want that. So the major human factors issue is to make sure that we reduce these, in particular in regular operations, so that the air traffic controller can better control their workload.
Very well said.
So I think that is it, and that involves all of these issues that were mentioned, for instance, an appropriate level of trust.
Thank you, Jonas. Next question is with Peter. Peter Oliver would like to know, did you take into account to use a assistance-based speech recognition to further reduce multiple tower controller workloads?
Yeah, basically yes. So that's one of our research topic, because we know, especially from large airports as a VCS provider, that the major limitation at large airport operations is the radio traffic. So here the controllers have the issue that they can't talk more than they do. So, and that's the limitation for capacity of large airports. And the same of course applies to a multi-remote tower environment. If you have 3 airports simultaneously and you have the frequencies coupled, then this also means that you have 3 times of the radio traffic you have normally. So, and that's one of our research topics.
Okay, thank you. David, next question is to you. Dr. Nimrod would like to know from you whether digital tower technology can be enabler for Southeast Asia, just like European Union has become have a Eurocontrol. Can that enable that?
Yes, I think this is a good question. We are projecting a 5% increase in traffic over in the Asia Pacific arena. And unless we move beyond what the human can cope, it is important for us to be able to guarantee safety and efficiency as the load increases. So I think that as we get into the more digital world, augmented assistance in traffic control system, in the air traffic management system at the global scale, it's important because we are no longer limiting ourselves because of connectivities for communications, for navigations, and for comprehensive awareness beyond radars and terrestrial means to satellite. So increasingly, you want to expand the distance of control beyond the airport to the en route to the oceanic area, all the way to from airport to airport. So I think digital tower helps to augment and reduce the workload. And in fact, it can be the safest and safer way of augmenting what is currently done in the traditional way of air traffic control. And I believe that as we go on this mode of augmenting the human and not replace the human, people, controller can be more trusting.
Sure. Excellent. Thank you. Niclas, Minton would like to know that with the Saab technologies, is it possible to reduce the safe separation in the digital tower environment, especially the TMA and the approach area?
Yeah, I think I'm not sure I can answer it fully because I think separation has many aspects of it in terms of surveillance and so on. I mean, if you have remote tower, which is more, it's the sensors that you apply and include in for your controller's abilities, and I think is linked to, I think the digitalization environment, as you've seen in this, can help you to provide tools for the controllers to apply better sensors technologies like surveillance and MLATs and WAMs and satellite-based things as much as you can. So I think there's not I cannot, with my knowledge, see a direct link that you can just say, well, the cameras will give you less separation. But combining that with the digital ability to present things for the controllers, with the sensor that you have, the assets that you have, I believe that would lead eventually to a new discussion on what are the figures for the separations and so on. Sure. That would be my, and the automation tool, as both me and Peter and others were talking about. So and also Dave in the end. So I think it's a combination of things. I think that would be my knowledge about this, at least at this stage. It's about efficiency and making use that you really can push the aircraft through, but you need to have a broader picture to answer that. That's my answer.
Thank you. Very good. Billy, Kai Xiong wants to know something, that you have only talked about good things when the digital tower was used by the LFE controllers. What were the bad things?
The bad things.
Headache, nausea, what happened?
Yes, I'm visiting the remote towers center. I only meet happy people. Actually, it's very, very social and very well organized. But I mean, the road to go there, that was kind of tricky thing, because somewhere it would be about to move people from one place to another place. And also bring in a new competence. So you need some training. But that has not been a problem, because that was far easier than everyone anticipated. The training was so easy because the new operations and the system was so well designed and easy to learn, and you have good support. But of course, moving people, that's always really tricky. And you may say, if you start an RTC somewhere now, recruit new people to that.
Sure.
But also recognize the experience and all the experiences from the old controllers, but it might be difficult to move people. You might spend too much effort on that instead of recruiting new people. The people I showed on my last slide.
Sure.
But from an NSP point of view, if you're looking back, I think that would be smarter.
Indeed. Yes. Great,
Wow,
thanks.
interesting. It's also impact to the training, how you do the training and how you perform the training, and how good you can have, which kind of performance you can have for the actual training also. So challenging. Yes.
Interesting. Jonas, Dr. Iman is very critical about data, and she's asking whether the human boss is ready to take the responsibility of the errors made by the digital assistant.
Well, that is the core of our reskilling effort here, right? To be able to understand, for the air traffic controller, to be able to understand the competence of the digital assistant. What can it do? What can it not do? To be able to safely delegate to the data without getting these hot handovers that I talked about before, right?
Right.
And that's something that we need to add both in training and in operations.
Certainly.
And that is the core of our research, to work on these training technologies and visualizations for operations. So that is the core issue, to be able to build a correct picture of the competence, which will, by the way, change as the technology evolves.
Sure. Great. Peter, Mohammed Alijimi from Eurocontrol would like to know, how do you do a cost-benefit analysis as a private company for the remote tower technology? How do you price safety? What happens if something goes wrong? One fatality in this digital environment, how do you cost that?
Well, basically, I want to point out that, of course, we do not do any compromise on safety. So if you would implement a technology which would be with a lower safety level than it's existent today, then it's for us clear we won't provide that, and that would never be accepted by the customer. So basically we calculate that in the same way as such safety issues have been calculated in the past. So if the safety level would be lower, we wouldn't sell it. That's simply as that. Sure. Excellent. David, one of the next question is to David. David, one of the attendees would like to know whether this sudden growth or the projected growth in the air traffic in Southeast Asia, can digital tower technology be a key enabler given the cost saving and lack of manpower that we have in Southeast Asia in this region? Tell me about that.
Yeah, I think the potential is there. I mean, if you look at the cost of tower, at least you need to spend in established airport about 100 million to build a tower. And even if you have the money to build more and more tower, when the tower get more complex, to increase the coordination between tower across distances is just not the most efficient way to do it. And given that the limitations of what the air traffic controllers using eyeball could do, there are blind sides that he can't see. And cameras plays an important part of it. So from the safety point of view, there's a lot of motivation to be able to ensure that instruction given to aircraft are followed or not mistakenly misinterpreted and cause a ground incident. So I think that the safety consideration will override the cost consideration. And when people begin to have more experience and trust EO systems that are getting a lot more emerging and more trusting and better than what the human eyes can see, both for day and night and for very challenging environment, then we can provide what we call the evidence-based operations to be able to slowly convince people to slowly calibrate their movement into tower from the conventional to the digital.
Sure. Excellent. I just have pose one more question to the panelist, and then in the interest of time, we will close the webinar after that. So the question is from Yanjun from MIT. Yanjun is asking Billy, how does a controller maintain situation awareness if he or she is managing more than 2 airports with different operating conditions, such as weather? So will the workload be significantly different between switching from one screen to the another? Remember, this is similar to the Uberlingen disaster, where one controller was managing 2 screens at the same time. One was the en route airspace, and another was, the ramp aircraft pushback. So, Billy.
Yes, situation awareness, that is key, of course, to the decision making and to maintaining safe operations and be on top of things. So that is a big concern, of course. What we see, what we try to push, we try to find the limits for the situation awareness. And actually, we started many years ago, 2017 or 16, to push it a lot with 3 airports simultaneously, a medium-sized airport, and we put 2 controllers in front of that, run several sessions, and they managed it. And we didn't really believe it. Anyway, there is some factors that comes up when you digitalize things. You have the queues in front of you, which also improve the things. It gives you better control over the visual cues. You have to organize and base your decision on. And also the information could be more well organized. So we haven't seen a kind of blocking point for that. And in the meantime, we like to add things like soft visual cues, speech, support speech recognition things, and attention guidings and so on. But this is measured, of course, in the validations, and so it's so important to be sure that the situation awareness are there for the controller to make safe and efficient decisions. We also have the ability to moderate the information presented to the air traffic controller by moderating the traffic also to these airports, and also use kind of data to support the controller, which could be really, really helpful support. Thank you.
Thank you so much. And with that, I would like to invite Dr. Michael, Assistant Director for the Saab-NTU Lab, to wrap up and closing remarks. Mike.
Hello, good afternoon. Hi, thank you very much for attending this webinar. I'd just like to say that the speakers have been very, very good. And I think the participation has been brilliant as well. So I'd like to really thank everyone who participated, not only because of the challenges here in terms of having remote things, but also we have been graced with such wisdom from the various speakers in an international arena of speakers here. So with that, I actually would like to just say thank you for the organizers who have empowered us to basically have this webinar. And I'd like to introduce you to the team, the webinar committee. So very briefly, we'd like to show you our setup here in the Saab-NTU Joint Lab war room, if you may. And so in the team, we have Prof. Samir, Dr. Jovice. Yes. And I'd like to just give thanks. Without the help of our webinar committee, this would not have been possible. So may I ask maybe each one of the committee members to just say hi in the camera. To say hi. It's active over there. So we have Dr. Nimra Dilith, who was the gentleman that has been collating your questions into what our moderator has then thrown back to the speakers in terms of the discussion this afternoon. We have Dr. Yix, who has been tremendous in supporting from the aspects of IT and also marketing and generating interest in the networks that are involved in ATM. I'd like to also thank Wei Shen, who is a Saab engineer here in Singapore, working on ATM research, focusing on human factors. He has been also supporting the webinar committee in all the tests and all the rehearsals, and giving us a lot of feedback in the way that we've run this. I'd like to also give thanks to Ms. Biwi Ang. Yeah. And I think with that, I'd like to give thanks to everyone. And after this webinar has been closed, we will have an email sent out to you for a post-webinar survey to get your feedback. We would like to encourage you to please fill that in, just very simple, 10 questions. I think with that, I hand over back to Prof. Samir to officially close this webinar.
Thank you so much, Michael. As I mentioned that we have barrage of questions coming for the speakers. Unbelievable. People are so interested in this technology, I never imagined. We will be emailing you the questions, and I am sure that we'll be able to answer them, and then we will collate the answers and we'll send back to the participants for sure. And we look forward to have such events in the future, and I will be sending invites and look forward for your exciting participation as well. Thank you so much and have a great evening. Thanks a lot for joining the webinar, and I hope that we all have got something to learn from it. Thank you once again to the webinar committee, and thank you the esteemed speakers. Bye-bye and take care.
Bye-bye.
Bye-bye.
Bye.
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 Bye.